Hi there, so this is our second exercise, or look at exercise 6F. It's integrated hyperbolic functions again. So this is a real life example of a catenary curve. Catenary basically is the posh name for a cosh x curve. Now this one's described as an inverted catenary because obviously it's upside down, it'd be a minus cosh x, I suppose. And apparently it's in St. Louis, in Missouri in America. And then the second example of a picture one is this chain, and apparently when a chain hangs down, you have to ask the physicist why, but you get a catenary curve again, and this is just a straightforward cosh x curve of some description. You also get something apparently with electric fields, and also one, well, that's just highlighting this, you know, the fact that it comes up in real life. So just be aware that these aren't made up for the sake of it. They are actually useful. All right, let's do a few questions. Integration by parts. We've seen these before. So I'll start with u equals x. Notice, by the way, now I've changed this, not to a late rule, but actually a lathe rule. I see these two things broadly as the same. So I'm sticking with u equal to x, obviously du by dx equals 1. I've got v equals and dv by dx. dv by dx is the cosh, so this must be the shine. And when I integrate, I get uv, which is x shine, x, minus the integral of v du by dx, which is obviously just shine. Times them by 1 won't make much difference. And so my final answer is x shine x minus cosh x when I integrate it, plus a constant. And this broadly should say the same thing as that, x shine minus cosh plus a constant. So a few of these to do then. Exactly the same here. See, now it's x shine. I think the last one was x cosh. So u equals x du by dx equals 1 v dv by dx. This is obviously shine, and therefore this is cosh. So if I put them in, I get uv I equals uv is x cosh minus the integral, and now it's just integral of cosh, because I'm times by 1, and therefore I think I'm going to get x cosh x minus a shine x plus a constant. And these are nice because you only have to do them once. That's the same thing. Yeah. The problem comes when you get one like this. I know I'm going to have to do this twice because it says x squared. So let's start, because I know I'm going to have to do it twice. I'm going to write I equals u equals the x squared there, and I'm sticking with the algebra first. Du by dx equals 2x. And obviously v equals and dv by dx equals, and my dv by dx is cosh 2x obviously, and therefore when I integrate, and of course I'm integrating here, I get a half of shine 2x. Make sure you suss the difference between differentiation and integration there. And therefore my I suppose is the, well, it's uv x squared over 2 shine 2x minus the integral of, well, luckily a half times 2 is 1, so I can ignore that, x shine 2x dx. So obviously I've got to now integrate this, and this is by parts again. So let's get straight in. U equals dx du by dx is now 1, which is what you want. Your v and your dv by dx. So what have we got here? We've got, this time we've got shine 2x. So when I integrate that, I get a half of cosh 2x. So I come over here, I chuck all that back in my I. My I then is x squared over 2 shine 2x. Shine on this. Minus, now, minus this, which is the integral of, which is uv, which is a half x over 2 again, I suppose it would have been better writing, cosh 2x minus the integral of that times that, which is obviously just a half of cosh 2x dx. close bracket. So what we got here, we end up with x squared over 2 sine of 2x minus x over 2 of cos 2x. And the minus becomes a plus, and when I integrate cos I get sine. Well, I get half, and it's already a half, so I reckon it's plus a quarter of sine 2x plus a constant. Let's see if that actually works. In this answer it's that they've taken sine out as a common factor, but other than that it looks the same to me. They've got a quarter and they've had to double that. Yeah, so that looks the same. Third example. Now I've put a little note on this. You're welcome to try and work out why, but I reckon on this that the e to the x cos x example fails if you try to do by parts. So I'm suggesting instead that when we get these ones where there's a mix of exponentials and hyperbolics, we just change it. I don't think I should write here. I'm going to write up here. It's e to the x times by, what is it? Well, cos I've written down there is a half e to the x plus e to the minus, a half e to the minus x if I expand the bracket. And of course that is something I can just multiply out the brackets for. I get e to the x times e to the x, which is e to the 2x. Well, technically a half e to the 2x. Now remember, I haven't actually integrated anything yet, so I should put an integral sign. And e to the x times by a half e to the minus x. Well, I add the powers, they disappear. So I reckon I get plus a half dx. So this actually becomes quite an easy problem. Integrate e to the x, you just basically leave it alone, but you divide by that front number, so it becomes a quarter e to the 2x plus a half x plus a constant. See if I agree with that. Yeah, so actually it worked out really easy when you did it. So if you get ones with exponentials times by a hyperbolic, it may well be that's the way to do it. And my last question, I've got x cos 2x. Obviously we're doing it by parts again, so I'm going to try it up here. U equals x. Is it very similar? There is difference, I suppose, is it's got a definite integral, but other than that it looks the same. U equals x, so therefore du by dx equals 1. V equals dv by dx equals, I think I'm going to need to do this once because it's already got there. I get cos 2x here, I've got to integrate, I know that becomes a half of sine 2x. So if I put this into here, my integral becomes uv, which is x over 2 sine 2x minus the integral of v du by dx, which we can ignore the 1, and that becomes x over 2 sine 2x minus a quarter of cos 2x. Now normally this would be plus a constant, but here it's a definite integral. So I'm going to chuck 1 and 2 in. So if I put 2 in, immediately I get 1 sine 2. Now you can't really work these out very well, so that, you're not going to get great answers. Minus a quarter of cos 2. If I put 1 in, I get, that's a minus. If I put 1 in, it's 1 over 2 sine. I just realised that should be sine of 4, because it's 2 2's, and this should also be cos of 4. And it's only sine of 2 when I put 1 in. There you go, nearly a bad mistake. Minus a quarter of cos 2. Now, let's see what I reckon I've probably just got a decimal. Yeah, I have got it. So I reckon if you type that into a calculator, you get 19.6. It's worth having a look for me. Now, integration by substitution. It's actually, you can do this a slightly different way. I'll show you how to do this. I think I've already got this done. So remember, tan can be written as sine over cos. And you'll just by looking at this, if you differentiate the bottom, you get the top. So almost this is going to give me log of the bottom. Now this is the posh way of doing it. You use u substitution. You say u equals that, and therefore du by dx x, normally I'd write it like that, equals shine x. And therefore, when you chuck this back in, you'll notice the shines disappear. It just becomes 1 over u, and therefore it's log u. So that's the posh way of writing it, and just getting rid of u at the end gives you cosh x. So look out for that. You're expected to know things like that, those kind of proofs. Some questions, and these are mainly by substitutions as well. So if I start here by saying u equals, which one should I use? I'm going to say u equals, I'm going to start off with cosh, I think. I think I could have done either way round, but I'll start with cosh. Therefore, du by dx is obviously shine. And this is one of those ones that you can see the shine is already there. So when I chuck this back in, I get 3. So I probably shouldn't do it here, I should do it here. The integral of 3 shine x. And if I rewrite this as dx equals, I get du over shine. Du over shine. Oh, I've missed out my u as well. There's a u there. So the shines disappear. It's really the integral of 3u du, which is 3u squared over 2, which therefore gives me 3. Right, I've written it in a different way again. This gives me 3, and I'm going to write this as cosh squared x over 2. Now, that's the right answer, but this is an alternative way of doing it if you allow for a different constant. So there is a way to do that, but this way is just as good, so it's fine. So coth, what is coth? Now coth, of course, is 1 over than, and therefore really, and the one way of writing coth is rather than shine over cosh, which is what than would be, you write cosh over shine. And you can see again, if I differentiate the bottom, I get the top. So I know that this really should be the log of the bottom plus a constant. Log of the bottom plus constant, yes. This third one, I'll try and remember to put it into the space. So if I'm doing the third one, I suppose I can write u equals one of them. So I'm going to write cosesh. And I suppose it relies on you knowing that du by dx. This is one that I think was in the formula book as a backward one, which we could extend, but that should say cosesh. That's not very well written at all, is it? Let's write this down again. Minus cosesh x times by coth x. So it's worth learning these. So if I differentiate cosesh, I get minus cosesh coth, which is a bit of a mouthful to say the least. So anyway, du divided by that minus cosesh cosh, I'm going to abbreviate it like that, is equal to dx. And therefore I can come back to this, and I'm going to get, I shall write it here now, it becomes the integral of cosesh became u, let's write that properly, so that, then it says coth, but then it becomes dx, which I now know as du, divided by this thing, which is minus cosesh coth, coth x, that's coth. And you can see straight away that the coth x's disappear, but don't forget that cosesh is actually u. So even though I've written cosesh x, I know cosesh x is u. So this then becomes integral of u, the coths have gone, to u divided by u, minus u. So even they disappear, and I'm left with the integral of minus 1 du, which is just minus u. And u is cosesh, so it should be, minus cosesh x plus a constant. So quite a lot of work just to get back to what seems a really simple answer, but a lot cancelling along the way. Oh, this is one of those ones, I think, you basically, because it's got a higher power, so it's like this first one. But if you ever get these with a power of them, you always use the one with the power to be your u.